Well, since we're on the topic of small CRT monitors, let's look at a small CRT camera using I think it's a half-inch Saticon. It's a little black and white one that was part of the watch cam package. Since over the last couple of videos I've been showing off some rather small and unusual things like this tiny little picture tube here, which incidentally what I've done on this thing is I put it back in its cabinet. I've got it displaying. I don't know if my camera's going to pick this up very well or not, but I've got it displaying my I call that my rat cam. I have right above me, directly above me, there's a rat trap in the attic. I've caught one rat with it, actually, once, a long time ago. I found a rat up there. I guess it would be about 3 years ago now. I had evidence that there had been a rat up there from his calling card, so I stuck the rat trap up, and it took a while, but we got him. I haven't seen one since. But I left the camera up there just so that I don't have to go and get the ladder out and manually check it. As you can turn on the monitor, I've been using my little watch cam monitor. This one. That's the one I've been using to check it. I figured, what the heck, I'll just plug it into this little eyepiece. Make a use for it because I don't need to check the thing. I just kind of look at it every other day. I check it to see if there's anything there. Anyway, the watch cam. The watch cam monitor actually had a camera that went with it at one time. And this is the camera that went with it. This is actually, the cover's been taken off this thing. It's probably upstairs in a drawer in my other workshop. But as was the camera. The tube on this camera shot, so I don't think I'm going to be able to make this thing work. But I tried that before and discovered that the tube was shot. But anyway, I'll show you guys what this is, because this was kind of cool. Now, back in the day when Sony made the watch cam, and no, I didn't buy the watch cam myself. I got it through the shop that I worked at for next to nothing, because it was a product that Sony had discontinued, and it was in what they called their second inventory. It was a way that dealers could get a real deal on obsolete products that had been discontinued, or stuff that had gone through service, had broken down and been repaired under warranty, and had been replaced. And then items went into what they called second inventory. And all the manufacturers did this. A lot of the stuff that I got, I ended up getting, cheap through second inventory. When I bought my first DCR VX1000, for example, that camera was a $3,600 camera. The wholesale on it at the time was around $2,500, and I got one through second inventory for I think I paid $1,800 for it when I bought it. So it was quite a substantial discount. And usually what ended up happening was that employees at the dealership or the dealership would buy it themselves, for their personal use and get a discount. And this was one of those. It was bought by the shop that I worked at, and the guy used it in the shop for a while, as a surveillance camera, just to watch. We had the monitor in the back, and then he wanted to start recording stuff, and wanted it in color. So we put up some color cameras, and I picked this thing up for a song. I think I may have paid $50 for the whole thing, the monitor and the camera. I didn't pay much for it. And I used this actually when I lived back in about 1986. I lived in an apartment, and I used this at my apartment just to keep an eye on what was going on. Because what was cool about this, and I've misplaced part of the system, but this actually mounted to your door, right? This piece here mounted to the door. You didn't screw it on or anything. There was a 2-piece adapter here for it, and there was an extension to this lens here. And what you did is you unscrewed the peephole that was already on the door. So I had it in my apartment. You unscrewed the peephole, and you put the other part of the lens through, and that it was long. It was about 3 inches long or so, because it would go through the door and go through this. And you could take off this one if your door was a little thicker. You could take this piece off, or if your door was really thick, you could take both of them off. But you put the peephole through the lens, and then you would put it through the hole in the back here. Actually, on the front, I guess it was, because this lines up with that. And then you'd screw it on. You'd hold your camera up, and you'd screw it together from the other side. Screw it on there. Now, there's always going to be a bit of a gap. The lens is sticking out. So then what you did was you just turned this little Tighten screw here. And what this did was this extended, as you can see, that extended the mounting bracket to pull the camera away and pull the lens tight so that someone couldn't come up on the other side and unscrew the lens. That was what that was for. And then this sat on the back of your door and plugged into that monitor I just showed. And, you know, someone knocked on your door, you could just turn on the monitor and see who was there. And I used to just turn the thing on and leave it run because the apartment that I lived in was on the ground floor and my door went right into the lobby. So I could see who was coming and going into the building, you know, all day long. It was cheap entertainment to see all the shady characters that were coming and going, and watch the drug deals that were going down. You see someone, you know, ring at the door, you know, and well, I couldn't see the door because where my door was looking, but I could see the entire lobby right from the front door all the way to the elevator. It was great. And you'd see someone come down the elevator, go meet someone at the door, and have a 5-second transaction, and then go back to the elevator again. You know what they were up to. But anyway, I had this thing for many years, and eventually the tube failed, I believe, in it. I never fixed it. Anyway, this comes off of the bracket. Oh, and there's a little switch on the back. You see there's a little button switch here. What that does is that flips the picture, because you could use it as a camera or you could use it as a door monitor. So if you were using it as a camera, that wasn't pushed in and you had a normal looking picture. And if you were using it as a door monitor, that would flip the picture. Otherwise you'd get a mirror image. Anyway, undo the lock, and here's the camera itself. And this actually has a metal cover that slides around it, but again, I took that off a while back and never found it. It's got auto iris lens. This is a Saticon tube in here, and I think it's a 1/3 inch. It's a real small one, but there's the iris. Anyway, I think we'll put power to this thing and just see what happens with the picture, see if we get anything. I think I've even got the cord with the 4-pin plug. I'll have to go and look and see if I can find that, and see if we can power this thing up and just get a refresher as to what the symptom was on this little tiny Saticon tube camera. But I think I diagnosed it before as a bad tube. It was just blooming big time, and there was no more gain on the tube. Let me see if I can find a cord to hook this thing up. Actually, I did find the cord. Here. This is not this camera, though, that's on there. This is a different camera that, this one's in pretty sad shape. This is another old beat-up camera that I had used for, I think I had this was originally used as a rat monitoring camera at one point, too. This is an old black and white, it'd be a CCD camera. Look at how big they used to be. We'll have to examine this thing, all wrapped up in duct tape. This was, yeah. This was a joke. What was this? I don't even remember what this was from. But this camera, I think, was... There it is there. I don't know what that came out of. But this one here was, at one point, I just wired in I cut the end of the plug off when this other camera died so I could continue to use the monitor for, for monitoring stuff. I used to have this camera before, in the house before I rebuilt it. I rebuilt this house in 2002. I bought the house in 93 for a song, and it needed a lot of work. I tore it down and built a new house, but we used to have a problem with rodents getting into the attic. So I ended up putting this camera. This one would work with infrared, so I had an infrared light source. I did exactly the same thing that I've got in my attic now, just a different camera. This was the old camera that was used at that time. And it still works. It doesn't work very good. Looks like it's got a bit of an exposure problem, doesn't it? I'm sure the caps on this thing are all shot, but anyway, I'm going to recover this cord. And this is actually good that I found this cord. Actually, I found the cord a while ago, and the camera. It was in an old closet stuck at the very back when I was doing some cleanup, and I found this box in the back that had this camera stuck in it. Anyway, we'll look at this one. We'll look at this camera too, and just kind of study these really old, archaic junk cameras, and kind of like almost like a little bit of a history lesson of solid state pickups, because this is black and white, and this is going way back. This is you know, big 2 boards on this thing. It's got power supply on here and everything. This is quite the unit. What does it say on the back here? For continued safety, if I replace it with a F1 amp fuse. Anyway, let's get this cord hooked up so that I can use it to power up this camera. In case you guys are wondering what is this mess, this would have been to power an infrared LED, which I would have stuck on top. Say this was an old camera that I used. I stuck it up in the attic and just taped it up against one of the rafters and had it pointing down. That was all this was. And I had that monitor in the house and had the cables, the little watch cam monitor down, and I would just turn it on and look at it, and okay, nothing there, and turn it off, and it would power everything. It would power the camera and everything right from the monitor, which was kind of cool. So I'm just going to take the cable off this one. It's got power. It actually powers it with like 12 volts or whatever the power from the watch cam is powered up with. That's what it feeds down here. I think it's 12 volts. Anyway, we got power here on the white and black wires. Good question as to why they have both of them, but power on the white and black, ground, video, and the audio was the blue wire, because the camera did have sound too. Here's an interesting observation. This is the power that feeds the watch cam monitor, 6 volts. Now take a look at what comes out of this power cable that fed the camera. 6 volts in, 16.8 to power the camera. That little watch cam monitor actually has a DC to DC converter, because the camera obviously required more power. That's what I forgot about. That's actually kind of cool, because I could use that this power cable here on the watch cam. I can use this to power a camera that requires 12 volts. So I may have to reuse this this cable to power a black and white camera for something on the watch cam, because I think now the rat camera is going to just be on this. For what I need to look at it, that little viewfinder will do the job, just to check it once in a while. Okay, I've got the camera powered up, and I don't have a picture. I've got it on my plasma. I'll show you guys a picture in a second here, but I'm getting some noise. I can see that the amplifier is working, because if I go anywhere near the target pickup here, I get all kinds of noise on the screen. But as you can see, no picture. If I press that little button on the back that reverses the image, you get a bit of noise, but no picture. I'm pretty sure it was the tube that I determined was the fault on this thing before, because there's not a lot else that can really go wrong. We know that the video amplifier is working, because if I put my fingers anywhere near the pickup tube, I'm just picking up residual noise. So we know that the video amplifier is working, and we know that the scan drive is working. We got sync. What I don't know is whether there's any deflection on the tube. I'm sure that we tested that the last time this thing was apart, and I have deflection. It's just the tube itself has gotten weak, because I remember how it went out. It went out gradually. It didn't go all at once. It went out gradually, where the tube it went into very heavy blooming first, which is typical of the gain of the beam. When the beam starts to diminish, there's nothing to discharge the target, and the picture just kind of washes out to nothing, and then you end up with no picture whatsoever. And the iris is wide open on here, so it's calling for light. It's just not getting any. Now, one thing one has to be kind of careful with, even when working on something like this, is these things have a fair bit of voltage in them. For example, right here we have 323 volts. Don't you love vacuum tubes? So you get a jolt off one of these things pretty easy. 21 volts on the focus. 12 on the beam. So my voltages are there. It's just, this thing's just not putting out any. 170 volts. It's just not putting out a picture. In case you're wondering what that high voltage is for, that is actually applied to the actual target of the tube up here. So this is the actual pickup. I guess a little explanation as to how a pickup tube works will enlighten you as to how a Saticon or a Vidicon camera works. So maybe we'll go over that. Okay, in the camera tube, we'll draw it, not to scale, but here's our tube. It's the sealing point, and all the pins coming out the end of the tube here. And inside the tube we've got a filament, and we've got the cathode. So the cathode is down at one end here, which has got the little heater and the filament in it, and that's connected to one of the pins here on the tube itself. The heater's connected to another couple of pins, and then there's a couple screens. We call them part of the electron gun assembly. Just like all cathode ray tubes are assembled like this. We'll have a series of lenses, and these are some of them are connected together. Others are on their own pin for focus. For example, you've got a main, what they call a beam control, and a focus grid or focus control. And basically, what these are is, if you were to look at them, they're just a round, cylindrical type piece of metal with a small hole in the middle. And that's what focuses the electron beam. The electron beam shoots out from here, and it goes down the tube. Now, on the outside here, you've got your magnetic deflection coils. Unlike an electrostatic tube, which is going to have, like a CRT used in a scope, is going to have deflection plates inside that, because they use electrostatic deflection. This is magnetic. So you've got your deflection coils, and you've got your main magnetic focus coil also around here. And on the front, this is the target of the tube. So if we were to look at the front of the tube here, this is what they call the target area. And your lens focuses your image onto an area on the back of this tube. This portion of the tube is coated with a photosensitive material. So if we were to draw the target, if this is our target here, the front of it, the back side of this is coated with a photosensitive material. And what happens is the beam, as the beam is deflecting, the beam is scanning across this surface of the tube. So if this is the front of the tube here, the beam is scanning across like this, right? Scanning across all your TV lines, just like it would on a picture tube. Now, the beam itself is a constant current source. It doesn't change, unlike a picture tube where the beam is actually modulated to produce your picture. It's the exact opposite of what happens on your picture tube. On your picture tube, the control grid is modulating the beam's current, and the beam is drawing on the fluorescent screen, which makes the fluorescent screen light up. On the camera pickup tube, or cathode ray tube, because there's still a cathode ray tube, but on the camera pickup tube, Vidicon, Saticon, Plumicon, Nuvicon, all the different types of cons that they come up with, Vidicon being the first. Actually, Vidicon was the first of the small types of tubes. There was many types before that. There was image orthicons, there was Plumicons, what were some of the other ones. But in the small cameras, the Vidicon was the small version. And I can actually show you a couple of Vidicon tubes here. So what I have 3 Vidicon tubes here. 2 color tubes and 1 monochrome tube. This one's the monochrome tube here, and this tube, as far as I know, still works. This is an S4097, probably one of the most popular of the Vidicon tubes ever made. It's a Panasonic or Matsushita tube. This was used in both black and white and 3-tube color cameras, because a 3-tube color camera was essentially just 3 black and white cameras with a prism to split the light into red, green, and blue, and then they had 3 tubes, and the 3 tubes were running together. But here, if we look at, we can see the internal structure of this tube quite nicely without me having to show it off as a cutaway. But if we look down here, you can see here is the electron gun, right? And your control grid. I think this one's the control grid, or this might be the focus grid. And then the beam shoots along this accelerating anode here, and it's deflected magnetically externally onto the target. And this is the target here, this metal ring, which is front is glued on. It's actually not one solid tube. This piece is actually glued on, just like the face of a picture tube. So that would be the Fritz seal right there. So this is electrically charged, the target. And in the case of this little camera, it's charged to about 375 volts. Some cameras, it's charged a little higher than that. And as the beam deflects up the tube, now remember, the beam is a constant source. This one's a color tube, by the way. The difference on this one is it's got a color filter on the front. I don't know if my camera's focusing properly there, so we'll just zoom it out a bit. But this one's got a color filter on the front to dissect the light into red, green, and blue. Right? You can actually see them right here. That's the test. Right, you can't see the color filters on this portion of the tube because they're microscopic. But when they made the tube, they made test layers so that the tube could be visually inspected to make sure that the color filters were actually applied, and you can see them reflecting on that portion of the tube, which of course never gets scanned, right? But I guess it actually does, because the beam probably hits that in the vertical retrace before the picture starts. You can see the numbering on the front of that tube. You get a close-up of the color filters. Okay, anyway. As the beam scans the tube, it discharges this target area here. And depending on the light that's falling on the photosensitive portion of the tube, that will determine the resistance. You can actually see the little bit of a gap on this particular one. Does it show up on this one? Maybe it doesn't show up quite as well on this one, but you can see the gap on this one here between the last electrode and the target. So as the beam scans, it discharges the target. And because the target is a photosensitive resistor, depending on the amount of light that's falling on that point of the target will determine the resistance of the material. And the beam is discharging the target. The target voltage is applied to here through a very high impedance resistor, typically in about the 5 to 10 mega ohm range. It's very, very high, the high voltage. So the current is exceptionally low. As the beam traces, it discharges the target. And as it discharges the target, it causes the voltage to fluctuate. If the picture is black, there's no light hitting that area of the target, there's no resistance, so the voltage remains high. But if it's a bright area of the tube, as the beam passes over it, that's seen as highly conductive. The beam, which is negative electrons, are streaming up towards this positive charged target. They discharge it, because now we've got a path. We've got a path to discharge that voltage, because the inside of the target is coated with a semi-transparent conductive surface that on the front side that the light actually shines through. The light shines through that semi-transparent surface. That's why you get looks like reflection. It's a very thin layer of gold that's on the surface, and that has the resistant material applied to the backside of it. So the beam is discharging that. It causes a voltage drop, which causes the voltage on the target to drop. And guess what? That's your video signal. As the beam traces top to bottom, left to right, top to bottom, it creates an analog video signal that corresponds to the amount of light that's falling on the photosensitive surface. That is how a camera tube works. I showed you this one here. This is the defective one. This is the one that actually that little 1.5 inch camera viewfinder came from. This is the camera from that. This is a Sony. This is called a mixed field Trinicon. And I kept this tube is gassy. If I apply power to it, it's going to light up like a neon tube. So probably the seal here is probably broken on here. But as you can see, this one here, the target is actually, this is the target here. But this one actually has a light that shines, a bias light that shines on the front to improve the light sensitivity. I think that would probably come off. I think this is just a glass. This is just a filter that's on there, because you can see underneath there, you can see the target area. It's essentially the same tube as this one here. It's just Sony did their own little thing with additional filtering on theirs and additional components to improve the sensitivity of the what they call the Trinicon. And then they also had one called the mixed field Saticon mixed field SMF. And I've got a couple of SMF cameras that actually still work, that are 30 plus odd years old, and they still produce a half decent picture considering the technology. But this one here was shot. Anyway, that's basically how a camera pickup tube works. It's basically the opposite of a picture tube. And that's why you've got high voltage there on the target. So let's go back and do some more troubleshooting and see if I can get some life out of this little camera. It would be cool if I could get some type of a picture off of it. Taking this camera apart further than it's ever been taken apart before. Don't know what's going to happen when I remove these screws. But hey, I got nothing to lose, right? This should remove the lens. But then again, maybe not. See, this camera doesn't have it doesn't have plugs to unplug the boards. These are all soldered together permanently. So I gotta try and get this bracket off of here so I can see what's below it. Plus, we want to see that little tube. The only plug I can see on this is this one here. This is for the auto iris. Unplug that. Ah, okay, that's how it comes apart. There is the little tube inside there. Isn't that cute? That is a very small pickup tube. And I think we'll take it out of the cabinet so we can look at it. It has a wire attached to it as well. It's like all these Saticon tubes, right? It has a little wire on the front here. I gotta disconnect it so I can pull the tube out. This little LED, by the way, that you see here, this is the bias LED. What it does is it floods the surface of the tube with the bias light, which is supposed to. You would think, what the heck are they thinking? Why are they doing this? But that apparently that is supposed to improve the signal to noise ratio. So I just told the DHL guy where he could take his package and stuff it. I don't know what it was. Someone tried to send me something. I hope it wasn't someone trying to send me a donation. But someone tried to send me a package and they used DHL, and the guy shows up at my door, and wants $19 in brokerage and duties, and I don't pay brokerage and duties for things that are sent to me as donations, so I told him to return it to sender. So if someone sent me something using DHL, you're going to get it back, and they're going to give you the bill for the return shipping, because I don't accept broker charges. I'm quite specific when people want to send me stuff, whether it's stuff they want to send me for repair or whether they want to send me donations or even products to review. I'm quite specific that I don't accept broker charges, and that I don't accept anything that's shipped in by FedEx or DHL. FedEx is bad though, because they just drop it at the door, and then they send me the bill after the fact, and then I get kind of pissy because I'm not paying $30 or $40 in broker charges for stuff that's sent to me. I don't care who it is. If it's somebody sending me something for repair, as people that have sent stuff for me for repair have found out, the broker and duty charges and stuff gets added to the cost. But when someone's sending me something as a donation that's not going back to them, I'm stuck with the charges and I'm not accepting them. So whoever sent me something by DHL, they're getting it back. Because I just had a nice little conversation with the DHL guy, and I basically told him to take it and stick it, that I'm not paying the bill. And I feel better now. I don't see any light from the filaments on this thing. Let's just check and see if it's got any voltage. Would that be something if it was just the filament voltage was out? The thing is, I don't know which pins are the filament on this thing. It looks like the tube socket is hooked up to these two blue cables, one going to this connector, the other one going up to here. I'm just going to do some voltage measurements on here and see whether there's any voltage on here. Say it's so long ago that I looked at this thing, I'm pretty sure at the time I just condemned it as the way it failed. It looked like a tube that was getting soft, and I just left it at that because I really didn't have any much intention of fixing it. There was no parts or anything available for it. It was already an obsolete item at the time, and there was no parts, and I didn't have a diagram or anything, so I just kind of walked away from it. But let's just check the voltages here and see what I've got. 4 volts, minus 4 volts, minus 0.6, 5 volts, 1.2, 151, 1.2, 1.2, 1.2, and 151. See if I can feel any heat on the tube, because obviously if the heater's working, you'll feel it. Normally you can see the heater glowing in the back, and I don't see anything on here. Maybe if I kill the lights I might see something. Well, even in the dark I don't see anything. I do see the little LED glowing here, but I don't see any light in the tube at the back at all. So let's take the tube out of this thing and see what this little Saticon tube looks like. I still think the tube is the fault on this unit and nothing else, because I did go through this years ago, and that was the conclusion I came to years ago, was based on the symptom, because I saw how it failed, based on the symptom. And I don't have any service data for this thing, but based on the symptom of it, it certainly looked like the tube that failed at the time. These Saticon tubes are kind of a pain because they have this extra wire that's connected to them. As I remove the whole yoke assembly. wire attached up here. Okay, now I should be able to remove this assembly, and we can take a look at the actual tube itself. And this looks like it's this one's got a static deflection, not magnetic, because there's no yoke on here. Interesting. Saticon. This has got electrostatic deflection on this tube. Isn't that cool? So the deflection would come down through the actual tube socket itself, which is a little different because most of these use magnetic deflection, but not this one. No coils on here at all. Target. I don't know what that grid is for, but that's got to be an accelerator grid of some type. It was connected down to this. Actually, that might be the target itself, the preamp. And this one might be a bias on this because the Saticon tubes are a little bit different than the regular tubes. If we look at that other tube I've got, it's very similar to this. But it looks like the deflection is there's plates on here. If I can take the tube out of this thing, this is a Saticon, as you can see. It says right on here, Saticon. And this would be I guess this is well, it's a 1/2-inch tube. That for sure. It's a 1/2-inch tube. So I just put the little tube back in here because I want to do a few other tests on this thing, but I'm still convinced that the tube is what the problem is. But the Saticon tube, from what I remember reading on them, was slightly different than the Vidicon tube. Vidicon tube, you had your target, as I showed you in the diagram. Your voltage was applied to the target, and the beam discharges the voltage coming off the target and modulates that target voltage with the video signal. The Saticon tube is slightly different because your target voltage is applied on one side of the on one side of the grid, and the signal is read out. Instead of the signal being read out through the target connector here, the signal is actually read out from the front here. This is the video out that goes into the video amplifier over here. So they're just slightly different configuration inside, but what strikes me as unusual on this particular unit is the fact that this thing uses a electrostatic deflection, which I didn't expect. I expected this was the yoke coil and that there was going to be a plug, a connector on the top there, which of course it doesn't have because this is electrostatic deflection. So let's look at see if we can see the deflection signals deflecting the beam. So of course I'm not going to spend that much more time on this little piece of junk because I do have audio gear service sitting here. I just was just going through looking at some of these old little cameras and stuff, and old little monitors are kind of interesting. So that looks like that's my horizontal. Getting different pulses on here. I'll show you guys these momentarily here. That looks like horizontal sawtooth. So there's the horizontal deflection. And there's vertical deflection. And there's the other vertical plate. And this would be the other horizontal plate. So these are our two deflections, horizontal and vertical. That's on the board on the top. And then over on the side here, these will be the filament voltages, the focus voltages, and the beam voltage. So of course that's the DC. Two of these will be filament, and one of these is going to be the beam current. So yeah, we're back to square one. It's the tube that's shot. The filament is open. I measure the filament here on the meter. Pin 5 and 6. It should be the filament. Filament's open. There's the fault. As I suspected before, the tube was bad. It's just the way it went like 20 odd years ago. I don't know why I've been hanging on to this thing. I think I was hanging on to it just because it's got this little cool tube in it. Anyway, that's it for this one. We'll catch you in the next one. Bye for now.